This is the fourth and final method for solving a quadratic that you need to know, and we could be looking at completing the square. Completing the square actually was developed before using that quadratic formula we just looked at, and actually the quadratic formula comes from the process of completing the square. It's a bit more of an old-fashioned traditional mathematical method of doing it. So I'm going to take you through an example and then annotate another written example on the next slide. If we've got that quadratic there, we could use any of the three methods, but in the book it tells you to do this by completing the square. Now, completing the square comes from the idea that if we've got a bracket like x plus 3 squared, when I multiply it out, it gives me x squared plus 6x plus 9. I've got here, as you see, the first two terms from this equation, x squared plus 6. Again, another old mathematical term. When you square a bracket, you square the first, x becomes x squared, square the second, 3 becomes 9, and you get twice the product. The product is 3 times x, 3x, twice that gives you that 6x there. So when we square this bracket, we square the first, we square the second, and we get twice the product. Anyway, now I know that x plus 3 squared is equal to this. I'm going to put this into that equation. But what I've done is I've put in an extra 9 that wasn't there before. This 9 that has come from the end of that x plus 3 squared wasn't there before. So to keep the equation balanced, I have to add on a 9 to the other side. So that's the second step. I've kept it balanced. I can simplify it all because I can take away 9 from both sides. It doesn't always happen like this, but this makes the equation very tidy because I've just got a 0 back on there. We'll look at an example later on where this doesn't happen, just so you know that process. I can now replace that x squared plus 6x plus 9 with x plus 3 squared, because I know that is the same as that. So I get a nice tidy equation, x plus 3 squared is equal to 0. Opposite of square is square root, so I can square root both sides, which leaves me with just x plus 3 equals 0. Well, the square root of that is 0 because I've got to square root both sides, I should say. So x plus 3 is the square root of 0, and then I can just move that 3 to the other side, so I find out that x is equal to minus 3. As I say, the minus b plus or minus the square root of b squared minus 4ac, 1 over 2a, actually comes from this method, and you might find it more straightforward, but sometimes you will need to show that you can do this skill. These are the sort of questions you can get. So if we look at this one, x plus 10, the square we need for that will be x plus 5 squared. Because when I multiply that out, I get x squared plus 10x plus 25. Again, this would be fairly tidy because that would neaten up quite well. The first few questions do make it straightforward for you. The middle ones are a bit harder, and I'll be looking at one of these at the end, which is really a bit more awkward. This one here, x plus 6. When I want to square that, it's one example I did before. This one, different thing here is you've got a minus. So that comes from the square of x minus 4, because that 4 is half of 8 squared. And what I'll get this time is an extra 16 that I need to balance, which again will work with that. H is a little more complex because it's not obvious which square you'd use. I've written this example out for us. So it's actually, you're always going to be using half of the number in front of the x. So half of 7 is 3.5. You can do this as decimals or fractions, whichever you find easier. I've stuck with decimals because that's what most of you seem to prefer. So the square I'm going to use is x plus 3.5 all squared. If I work out what that is, it gives me the x squared plus 7 that I want for this part of the equation, but it also gives me 12.25. Take my word for it. So this is what x plus 3.5 all squared would give me, and I've also, remember, still got that minus 12 on the end there. Now, it's created that extra 12.25. So to keep it balanced, I have to add 12.25 onto the other side. I can now start tidying it up. So x plus 3.5 squared, which is what I want to get on one side, is actually equal to 24.25 to keep this equation balanced, because I take the minus 12 over there and add it on to what I have here, gives me 24.25 in total. Now this is when I can do the square root to get rid of that. So I need to square root 24.25. I've worked that out as a decimal, and remembering to put the plus or minus, because 4.9 times 4.9 will give me that, and minus 4.9 times minus 4.9 will give me that. This is to one decimal place. It is a longer decimal than that, but I've just kept it simple. So this is my answer, because I need to take that plus 3.5 over to the other side of the equation. So it becomes a minus. This is when I get my two answers. I get minus 3.5 plus 4.9, which gives me 1.4. And I also have minus 3.5 minus 4.9, which gives me minus 8.4. That is how we were going to do one when we've got a slightly more awkward number in front of the x. So for this one, when it was 11x, then you'd be using x plus 5.5, because that's half of 11 squared, and then go through the same process. For these ones, where we've got 2x squared and 3x squared, my preferred method is just to divide all of that through by 2. So when I divide 2x squared by 2, I get x squared. When I do minus 10x divided by 2, it leaves me with 5x. And minus 6 divided by 2 leaves me 3. And on the other side, 0 divided by 2 still leaves me with 0. And then similarly, this one would be divided by 3 to give me just x squared minus 2x minus 4, and again 0 divided by 3 is going to be 0. So that's again in a similar format that you can solve like this one here when you've got an odd number there. So completing the square is just practice, 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 like most things in maths. I prefer using the quadratic equation, that formula we used in the last one, but sometimes I say you will need this skill, so have a practice and you will get better and better as you go. Okay, next one will be simultaneous equations, so I'll see you in a day or two for that one. Loads more fun to come. Bye bye.